Hi everyone, today's SOS video is for Unit 12, Lesson 4. The main concept of this lesson was that exponential functions can show an increase or decrease over time. Important vocabulary to remember is that the growth is increase in rate R over time. Decay is where there is a decrease in rate R over time. Model is a function that represents the situation presented. To appreciate is to increase in value, and to depreciate means to decrease in value. Exponential functions can show an increase in time, where the common ratio or the factor would be 1 plus the growth rate. R stands for rate. Exponential functions can show a decrease in time when the common ratio or the factor, decay factor, would be 1 minus the rate. We can represent exponential growth models using the formula y equals a times 1 plus r to the t. Your y represents the final amount, a represents the initial value, the r represents the growth rate, which is a percent as a decimal, and the t represents the time. 1 plus r, when we add 1 to the growth rate, that is our growth factor. That becomes the number we are multiplying by each time. The exponential decay model we can represent with y equals a times 1 minus r to the t. Y is the final amount. A is our y-intercept. 1 minus r, or let's just say the r is your decay rate as a percent, change to a decimal. And again, t is time. The 1 minus r we can refer to as our decay rate. Let's take a look at example number 1. A helium balloon has 230 cubic inches of air and is losing 1.24% of its air every hour. Let's write an exponential function that models the situation. So we see that the balloon is losing 1.24% of its air every hour. So this represents decay. We're going to substitute into our exponential decay model formula. So we have y equals, we know that our a value, our initial value, is 230 cubic centimeters. Our r is 1.24% as a decimal, so that's going to be 0.124. Move your decimal 2 places to the left. We can substitute it into the formula here. Y equals 230 times 1 minus 0.0124 to the t. And then we can simplify that to get y equals 230 times 1 minus 0.0124 is 0.9876 to the t. After 7 hours, how much air is in the balloon? And we're going to round our answer to the nearest hundredth. How much air was lost? So let's figure out how much air is in the balloon. After 7 hours means we're going to substitute 7 in for t. So y equals 230 times 0.9876 to the 7th power. Okay, use your calculator, put that in. To get y equals, we get 210.76, and we're going to use cubic inches. Okay, so that's how much air is in the balloon after the 7 hours. So how much air was lost, the second part of the question, we need to subtract 230 minus our 210.76. So how much air was lost? When we subtract, we get 19.24 cubic inches. The balloon will start sinking to the floor when it loses at least half its air. In how many hours will that happen? So if the balloon loses half of its air, half of your 230 would be 115 cubic inches of air. So we want to know, when will this 115 equal 230 times 0.9876 to the t. So here we're looking for the t in the equation. When we're looking for that exponent, what we can do is we can use our calculators. We're going to go to the y equals. Let's put in our equation. Y equals 230 times 0.9876 to the t. So we'll use x to represent t. And then we're going to look at our table of values until we get as close as we can to 115. Keep going. All right, we're going to keep going, and we're almost there, close to 115 as we can get. Okay, so we have 115.79, 114.36. Which one is closer? And it's closer here to the 56 hours. So using our table of values, let's copy down here. At 55 hours, we have 115.79. At 56 hours, 114.36. Very close, but this one is closer. So 56 hours. Okay, let's take a look at example number 2. We have a baseball card that was valued at $520 in the year 2001. Since then, it has been appreciating at a rate of 9% per year. So when something appreciates, it grows in value. Let's write the exponential function that models this situation. So since we have exponential growth here, we're going to use the formula from before, y equals a times 1 plus r to the t. What is our a and what is our r? So the a is the initial value, which is 520. The r is the 9% as a decimal. So we're going to substitute in. So y equals 520 times 1 plus 0.09 to the t. Add these together, we get y equals 520 times 1.09 to the t. So this is the function, the equation that represents our situation. Okay, we want to sketch the graph of the function using the indicated window. So you see our y-intercept is 520. So your calculators are set to graph usually on the x and y axes from -10 to +10. But because we need a y-intercept with such a big value here of 520, we're going to change the windows on our calculator. So if you go to where it says window on your calculator, we're going to change our x min to 0, our x max to 20, And we're going to go by a scale of 2. So that means we're going to increase by 2 on the x-axis. For our y min, we'll go to 500. Our y max, we can do 3,500. And let's go by a scale of, maybe we'll go by 200. Okay. Now we can take a look at the graph. And our y equals 520 times 1.09 to the x. Okay, and then we can go graph, and then we get our exponential growth. See it there? Okay, so if we want to sketch that, let's start here at 500. Okay. And that's where our y-intercept is. And we know we have exponential growth. And our graph would look something like that. Okay, how much is our baseball card worth now to the nearest dollar? So remember, this was in 2001, and now we're in 2021, so that means over 20 years. What is the value of the card? So y equals 520 times 1.09 to the 20, right? 20 years have passed since 2001. And now we can just put that right into our calculators. Let's get out of the graph. And we're going to do 520 times 1.09 to the 20th power. And we get $2,914.29, but it says round to the nearest dollar. So that would be $2,914. Okay. Hope you found this video helpful. Thank you for tuning in, and we'll see you next time.